Okay. This is CS61B. Anyone who intends to take some other course, now is the time to find the right classroom. Let's see here. Now, I'm uncertain at the moment. Looking at the enrollment figures, I gather that we don't have enough account forms. So I'm going to hold off on account forms, and there's nothing due this week anyway, so it's okay. It'll work. Don't worry. We'll get those taken care of next week when I can get some more forms. When you do get your account, please. There are two registrations in this course. There's the registration with the university, which I don't trust any farther than I can throw it. And then there's the registration with me, which I trust because I wrote that software. So the latter is available through the class website. There's an administration link. You will, however, need an account before you can quote, re-register yourself. This comes with a background survey where we try to find out some facts about you and all that sort of thing. Let's see. So, well, I may change it. We'll see what happens. Okay, so also when we do finally get you account forms, try using them, try logging in from home. Those of you who will be using the instructional labs in SOTA, great news, we have shiny new workstations for you. Oh, they're just wonderful. Nice big screens, little Intel NUC processors. It's pretty good stuff. Seems to work fine. Nothing's broken yet. Now, and if you will please refrain from putting your feet on the walls and pouring soda into the keyboards, they may even last for a while. Okay. Meanwhile, in case you didn't notice, there were no discussion sections in labs this week. That's why the room was so empty when you went there. This was not a mistake. That's the way it goes. Now, I don't know, don't ask me what the situation is going to be with the waiting list and whether you're going to get on and so forth. These are imponderables at the moment as we do last-minute scrambling around. You may have noticed that the course limit was decreased recently for some unknown reason. That will be corrected, I am told. There will still be some people who are pending and also concurrent enrollment students. No, at this time, I don't quite know what we're going to do about that, although we may be able to open another section. Now, once the course gets going, we'll be using it will be mostly online. So the materials that we will use are online, and that includes the notices and discussions and so forth, which will take place on the notice board Piazza. I presume most of you have probably had some experience with that before, but you'll be able to sign up for that as well. Okay, now there is a general course information handout that normally I, wait for it, hand out. But in the interest of conservation and all that sort of business, we recently have been going to doing this online, but it is there. Please read it. And it will have all kinds of information on lateness policy, grading, that sort of thing, so that I don't have to go and lecture on it, because this lecture is not exactly the best forum for revealing that sort of material. This lecture and other lectures will be screencast. That means you see this and you hear my dulcet voice, but you won't see me, thus saving yourself undue strain and all that sort of thing, and allowing me to wear snazzy outfits like this one. All right. There are two readers for this course. They're online, I will not assign all of them, but I will assign material out of them as we go on. All the data structures material is going to be in one of those readers, which it's a reader that I have written. I don't have you do a textbook for this course. There are certainly lots of data structures textbooks, but they're all hideously expensive, and so long ago I decided the students might as well be able to do this for free if they have laptops. So there is, however, one textbook for Java. It's pretty cheap. It's not exactly the textbook that I would have chosen for teaching myself, but according to my colleagues who has actually done a study of this, it seems to have all the right material. And so if you can stand the sort of cutesy attitude that it takes, you can get useful information out of it. Now, yes, yeah, so anyway, that's how that goes. And by this time, I think you can get them used and all that sort of business. Now, ideally, what I would like to do is to have you read the material and then have the material be illustrated. That doesn't always work out that way because for some reason, people don't like to read anymore. Now, of course, I'm just the sort of guy to say, well, okay, too bad, then I guess you're going to fail this course. But my department chairman tells me to sort of hide that attitude as much as possible because it scares the students. Now, the thing that I like to do, of course, is lecture. Every professor is probably that way. But what are really important, but to be perfectly honest, that's not where you learn the material. You learn the material by doing it. So we have labs where you can go and do exercises in the presence of TAs, which is the main purpose for having labs. And there are also homework where you go and practice. And these things, these two activities, are not really seriously graded. I mean, you can sort of get by with a lick and a promise. But we give you points in order to encourage you to do them because that's how you learn things. We don't evaluate you particularly by them, although we will notice if you keep skipping homework and labs. I mean, after all, they're easy points, and if you skip them, that probably means there's something wrong. So don't skip them. Keep up with everything, and that will be, you'll find that that's very helpful. And to encourage this, as you'll see in the course information handout, we don't allow late submissions. We're actually kind of lenient the first few weeks, but we don't accept homeworks submitted well after the deadline because that would just encourage people to pile it all up at the end, and that's not a good idea. Now, the really important part of this course are the projects, is the set of projects. This is where you actually go and write a program with decreasing degrees of framework provided for you at the outset. And that's how you learn to do anything, any skill or any body of knowledge like programming. You learn by actually doing it. So the projects are really important. How many of you have heard of my reputation? Anyone who did not raise his or her hand, check with your neighbor who did and find out what it is that they know that you don't. Okay? These projects will take you a long time. Go to your calendar. Postpone your social life for the next 4 months. In the process of doing this, you will be using various tools. We keep the tools simple. I mean, there are these really great programming interactive development environments, IDEs, programming environments all over the place, like Eclipse is very popular and so forth. We just stick with the simple basics so that you can see what's actually going on under the hood. And because it would be the straw that broke the camel's back if we were also teaching you some significant and elaborate IDE as well as everything else. So we try to keep it simple. But that doesn't mean you can't use, if you have found a great development tool and you really like it, then by all means use it. It'll work. And you just have to make sure that at the last step where you submit everything that it actually runs on the instructional machines. So So when we ask you, however, to do things like debug a program or use the version control software, which you'll be using to submit your assignments and so forth, they're important. I mean, if I wanted to, I could ask you questions on the test. Maybe oh, gee, that's a good idea. Ask you questions on the test about them. So do make sure that you don't think that this is just about very narrow questions of Java syntax. It's not. It's about the whole process. My tests are known to be challenging, but I believe, on the basis of observation, that Dan Garcia's tests are harder. So if you've been able to deal with them, then you can probably deal with mine. At least you should tell yourself that in order to keep yourself from becoming terribly anxious. Okay, so the breakdown here, as you say, equally weighted between tests and projects, with homework thrown in to as a sort of an impetus. However, I realize that that it will be a lot of work. People do tend to get stressed. That's bad. Do come and talk to us. Do come and talk to us about this, which us meaning me, the TAs. When you find it, sometimes it's a matter of getting some feedback to me that, oh gosh, the whole class is on the verge of a nervous breakdown. Maybe you should slow down a little, or oh gosh, the class is entirely bored. Maybe you'd better step up the pace a bit. That one or the other of those. The subject matter of this course is programming. Now, by programming, I don't mean apparently what other people mean by programming. People say, oh, computer science is more than programming. I ask them, okay, well, what else is it? And then they list 3 things, and I say, oh, those are all programming. What are you talking about? I take a rather expansive view of the notion. But in any case, it is certainly not just Java. It's certainly not just Windows. God forbid. It's not even... It's certainly not even just Unix or Mac OS or anything like that. These principles of programming that I hope you pick up here span many languages. Yes, we all write our code in Java, and yes, you'll sort of get into the Java way of thinking, but what you find once you have learned, say after your first 30 or so programming languages, you realize that many these things are really just the same. They hide behind these veils of syntax, but they're really underneath, there are a lot of similar features. And what you should find yourself doing while you're learning Java is, assuming the previous course you've taken is Python, uses Python, you should say, okay, well, how does each one of these features map into Python? And you'll generally see that there's a fairly close correspondence. So the important design and the important ideas are the same. Furthermore, whether the things that you're coding are graphical user interfaces or textual interfaces, embedded systems, those are the things that fly around in airplanes and cars and so forth. They're going to be increasingly important. But the underlying principles at the base really are quite similar. The principles of the low-level programming primitives and the principles for organizing programs. These tend to be the same. Okay, so for the next session, I'm going to ask you to read this chapter 1 of Head First Java and some sections of the online notes. So that would be, next time will be Wednesday. You actually get Monday off, I mean, Labor Day, it ruins entirely it'll ruin my rep giving you holidays in the middle of the course, but there you go. Okay, so these comprise sort of an overview of the major features of Java, and then we sort of spiral around looking at them in more detail as we go on. But this is just the first part of the course. After that, we'll start we'll get into algorithms, data structures, and the more interesting and general stuff. And if as a result of this reading you get questions, then for heaven's sakes, post them or send them by email. I don't know if we're going to, I don't know when we're going to get on proper piazza duty, but at some point we will start answering. And also, you might even get answers from other members of the class to some of these questions, some of which may actually be true. Now, 2 phrases of advice. DBC, don't be clueless. There is a great tendency among civilians, by which I mean the people that you will be producing software for in the future, great tendency among civilians that when something goes wrong or something happens, they won't necessarily understand what's really going on. They will have very limited, their understanding of software is sort of like the sorcerer's apprentice. You know some magic words and they work, but sometimes if you forget to learn the magic words that stop what you just started, you may get into serious trouble. And you don't really know how to invent new magic words in order to do what you want. But you are different. You're supposed to understand all of this stuff. And that means that when you are confronted with things that don't make sense to you, such as a program misbehaving when it shouldn't be misbehaving, or a piece of software that's not doing what you expected to do, well, your sensibility should be, gee, I should be able to figure this out. I should be able to see what's going on. I should not be in the dark as to what's going on here. So this is it's sort of a call to be curious, if you will. So something strange happens. Why does it happen? You, especially when it comes to dealing with, for example, our submission software, you say, homework submit, blah, 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 and you get this funny error message, okay? You can't just say, oh, wow, I got an error message. I guess I'll go have dinner. No. Your homework will not have been submitted. I mean, something will have gone wrong. Don't tolerate that. Get it to work. And it might require banging on it, kicking something. It might require asking questions. But whatever it takes, don't allow yourself to be hijacked or sabotaged by what ought to be minor problems. Okay, and then, excuse me, I have a cold. Then, of course, there's this famous motto, RTFM, which stands for read the manual. Yes?
I didn't get that third letter.
I've got my eye on you, son. We have gone to a great deal of trouble, myself, sometimes the TAs even, to provide you with and also all the people at Oracle and all these other companies that we're dealing with, to provide you with lots of written information. And it hurts me when you don't consult it. Now, you will know that you have been failing to consult the manual when my answers on Piazza or email or whatever begin like this. Well, let's look at the spec, quotation from homework assignment, and then my name, thank you, that's it. Okay. When you see a message like that, it means it's my polite way of saying, you didn't read this, did you? Right? And it has the answer to your question. So I think the world would be a much better place if people obeyed this particular maxim. All right, oh good, we have plenty of time left. So there is a contest upcoming, currently scheduled for the 28th, it's a Saturday. Yes, I know it overlaps the hackathon, but I've been there first. This is a little programming contest, one of these things where you're given a bunch of problems, you have 5 hours to solve them, 5 hours to write programs to solve these problems, and it will be a qualifying run for the ACM contest, the Association for Computing Machinery contests, collegiate programming contests that happen later. I don't know where the next international contest is going to be. They sort of hop all over the world, but they've had some in some pretty nice venues, so it might be a good thing, like Hawaii, for example. Yeah. Good stuff. So it might be good to get in on this, especially since at the moment, China and Russia and Eastern Europe sort of dominate this competition. Back when it started, the university that founded this thing in Waco, Texas, won the contest, and they haven't won it since. We won it in the 90s. We haven't won it since. And actually, there wasn't, I don't think there were any, I don't remember that there were any US teams in the top 10 this time. So we've got to put a stop to this. And this means that people have to get that sort of bloodlust for winning programming contests. So I hope that some of you might just sign up for this. Okay, I'm going to take a brief pause now for a breather and comments. I'm actually going to start doing a first pass over the next lecture. Just since you haven't read anything yet, it'll be necessarily brief, and we'll do it again on Wednesday. But it might give a chance to get some of the juices flowing. So first of all, questions on anything I've said so far? Yes.
Do we need head-first Java particularly, or could we look at some other
Do you need head-first Java particularly? Well, that's an interesting question. I'm trying to think off the top of my head whether the homework assignments make direct reference to head-first Java pages, or whether they just copy the assignments out of it. If you're good at this sort of thing, or think you are, and want to be disabused of that idea, then I suspect that you will find that any Java text that you're comfortable with will probably work. But do be prepared for the occasional glitch if having to do with a particular homework assignment or something like that. Maybe you can get an old beat-up copy of head-first Java and then a real manual or something like that. I'm not sure. Why do you ask, by the way? Do you have a book already?
No, I was just wondering.
Oh, okay. Yeah. Certainly, if you find that head-first Java is irritating to you as it is to me, then by all means try to find something else. But it's generally, it's not particularly expensive, and it seems to work. So, you know. Anyone else? Oh, that's good. Let's take, say, 3 minutes and breathe, wake up, that sort of thing. Thank you. All right, just to pass the time here, why don't we take a first look at a little bit of Java programming and a particular approach to solving a problem. Now, I haven't asked you to read anything about this, so undoubtedly this will all be very mysterious, but that's okay. You'll have seen it once, and when we do it for real next time, it'll perhaps come a little easier. So here's my problem. I'd like to have a program that computes prime numbers. In particular, I'd like to be able to have a program. I'd like to be able to write on my command line Java primes, for example, Java primes, and give a number, an upper bound, and have it print the numbers up through that upper bound, the prime numbers up through that upper bound. I hope everyone knows what a prime number is, but just in case, it's an integer greater than 1 that has no divisors smaller than itself other than 1. So it's indivisible by, it's not evenly divisible by any other integer other than 1 and itself. There are a couple of useful facts that you should know about it, which is that if you can, if some number k divides n, then n minus k also divides n. So this is just, not particularly surprised. By divides, I mean divides into evenly without a remainder. And there's also the fact that if k is less than or equal to n to the square root of n, then n over k is greater than or equal to the square root of n, which means that, I should have said vice versa in both of these cases, which means that once you've checked n, you've also checked k over n, and as it turns out, that means that you've checked all the potential divisors up to and including this. Once you've checked all the potential divisors up to and including the square root, you've checked all the divisors you need to check. So this is kind of a useful piece of information that we might use later. Well, the first thing we're going to do is have a plan, and this plan has the side effect of illustrating what Java programs in general look like. So the principal unit of division in Java is something called class, which is basically a collection of definitions. So if you look at the structure of any programming language, what you find is that there are some primitive types of value that you can deal with, like, for example, integers or what have you. There are some primitive operations upon those values built in. There are some constructors or some constructs that allow you to sequence operations and do them conditionally and all that business. And then finally, there is this definitional component, the thing that allows you to define things and give them a name, define procedures or data and give it a name. So that's what that's sort of the high-level orientation of Java program, is a bunch of definitions of things. So, for example, I have a primes class. I describe and then in this class, I have a bunch of what are called methods or functions or procedures that encapsulate some action. You've already seen, I think, all of these things if you've taken the Python course, or CS61A. I should not call that the Python course. I should call it 61A. Or for that matter, 9H, which is the Python course. You've seen all of these concepts, the concept of a class, the concept of a procedure or function, the concept of a definition. So as you can see, in comparison to Python, Java is the same thing, except it's rather wordy. Well, this is just a cross you have to bear, or whatever the equivalent is in other religions. So methods are basically described as you see here. We have the name of the method or the name of the procedure, And in addition, which you haven't seen in Python, we have something that describes what its arguments are, what parameters it takes. What you don't see in Python, usually, are these two things here. This thing that says void and this thing that says string bracket bracket. These are types. That is, they are declarations of what kind of value is expected to be produced, namely in this case, none, and what kind of value is expected to be put into it. In this case, an array, see, bracket bracket, an array of strings. And a string, if you've seen strings in Python, that's not a bad way of thinking of it. So what this says is that this is a function. It is enclosed inside this class primes. And this is a function called main. It doesn't return anything, and it expects you to give it a list or an array. I better say array, an array of strings as its argument. Now this is in fact the place where Java programs connect, or one of the places where Java programs connect with the outside world, because the convention is that when I say Java primes later on, that means call the function called main that's defined inside the class called primes. Now this extra stuff out here, public static, is, as I told you that Java was wordy, you don't have to say either of these things in Python. Static means this is a perfectly ordinary procedure, period. Namely, it's just a procedure. It's just a function. There's nothing else. That's all it is. I know that static is a rather strange way to describe that, but it's history. That's the way these things go. And public means it can be accessed freely from outside the class primes. So how am I going to print? So my job was to print all of the primes up to u. And u will initially be, and so I will print all of those out. And how am I going to do that? Well, gee, you know what would be really nice to have at this point? What would be really nice to have is a procedure that I give it a number and it prints all the primes up to that number. Wouldn't that be useful? I mean, for solving this particular problem of printing all the primes up to a particular number? Yes, it would. Okay, well, let me just wish upon a star and just invent it. So here, I will say here, I have declared that there is a procedure called print primes. I give it a limiting value, and it doesn't return anything, but it will print all of these. Primes. However, I don't know how to implement that because I'm lazy. I haven't thought about it. So I'll just make this little thing. This is a comment that says, that sort of promises me what it's going to do later on. So I'll just put, for the moment, I'll just put a comment in there, not a real body. But what I will do is say up here exactly what I intend the procedure to do. So this is, obviously I didn't have to do either of these things. Comments are things that are ignored by the compiler, so they're always optional. But they're good for us the programmers. So then finally I need to know how I take a string of characters, individual characters, that happen to spell a number, and I turn that into something that the machine thinks of as a number. And in this case, there's no way to figure this out. You just have to know that in Java there is a class called integer with a capital I, and it contains, among other things, a convenient little method called parseInt that parses, that takes a bunch of characters that happen to be a number and a numeral and converts that into a number. So here I now have a procedure that is supposed to print all the primes up to arg0. And I have written its implementation right here. I say I call the print primes procedure, and I pass it the arg0, interpreted as a number. And I look down here to see what print primes does, and I look at the comment, of course. What else would you look at? You wouldn't look inside the body. I mean, gosh, that would be complicated. No, I just look at the comment, and it says that it prints all the primes. So I know that what I've got here is this is a correct program right here. This is the correct procedure. I know it. I'm done. I've written it. Even though I have no idea how to write print primes or anything like that, it doesn't matter. This is correct. I can actually, in the absence of the whole rest of the program, I can still point at this function and say, I can see that this is correct. This may sound like a trivial point to you, but it really isn't. This is the way that you take a really big problem. This is an illustration of how you take a very big problem and you break it into little pieces and do it one step at a time, without having to write the entire program and only then have any concept about whether it's going to work. Okay, and then I'm going to sort of, now this is a sort of what we call a top-down development. I figure the things that I need at each step, and I sort of driven from the thing that I want to do, I figure out the things that I still have yet to do. Now I'm going to do a little bit of what's called bottom-up development. I'm going to say, on the basis of my long experience, after all, I do have a PhD in computer science, I predict that it will be very useful to have a function is prime. In fact, I've mentioned it right here. So I print it if is prime of x is true. So I've declared here in anticipation of this need, I have declared a function that returns, in this case, it returns a Boolean. That is a yes/no value, true or false. And it takes an integer as its argument. And it returns true if and only if x is prime and false otherwise. You might have noticed that these two methods are both static, meaning they're ordinary, but these are private, meaning that you don't use them outside the class primes. We will discuss at some point the rationale behind public versus private, but the basic idea is that that the user of a class should have to know as little as possible, as little as necessary to make use of the class, and shouldn't have to be bothered with inner details. And so the word private here marks inner details that you shouldn't have to know about outside. Think of it that way. Okay, so carrying on my plan, I have now broken this problem down into pieces. I can tackle any piece I want in isolation of all the other pieces. This is another great lesson in programming. It's universally applicable. That is to say, the whole idea is to succeed in separating your program into into pieces that interact as little as possible, so that you can do each one of them you can build each one in isolation. And that means that, for example, if you've got a team of 3 people, you can set Joe off on this class and Sam off on that method and Jane off on this method, and they can work usefully together because they don't have to talk to each other. So separation of concerns is a term that's sometimes used. So I had that method is prime, which I didn't copy down the comment, but its comment is that it's true if and only if x is a prime. And how am I going to do this? Well, let me see now. First of all, what do I know about primes? There are many ways of thinking about this particular technique that I'm about to unveil here. One way of thinking that this is called I call it the method of guarded commands, or it is called the method of guarded commands, which is you think of what could be possible answers to this problem, and then you think of what are the conditions under which that answer is in fact correct. For example, the answer to this problem might be false. Well, can I think of a condition under which I'm pretty sure in which I'm really sure that the answer is going to be false? Yes. I know that primes have to be greater than or equal to 1, so I can be pretty sure, so I can be darn sure that if x happens to be less than or equal to 1, the answer is false. So I know, even though I haven't written the rest of the procedure, I know that these 2 lines are correct. Amazingly, I know that those 2 lines are correct, even though I haven't written the rest of the procedure. Would that all of our programming could be done that way. So you can actually break things down piece by piece. And now in the case that is else, which is to say, which is sort of short for x is greater than 1, all the other cases, then x is prime if it is not divisible. Well, it would be useful if I knew whether it was divisible by some number greater than 2. I ask to see whether x is divisible by some number greater than or equal to 2. And if it isn't divisible by any number greater than or equal to 2, then the thing is prime. So this is divisible thing, where I've defined is divisible down here, to mean that it tests to see if x is divisible by some number that's greater than its argument and less than the number itself, assuming that x is already greater than, or that k is already greater than 1. So assuming that this comment is correct, I can tell right now that this function is correct. I can figure out that this function is correct based only on this comment here and my knowledge of what prime numbers are supposed to be. Of course, I may not have implemented this yet, but even before I've implemented this, I can make that determination. Okay, how do I do is divisible? Well, let's see. I look to see, I'll use this same guarded thing. Say, well, let me see, when do I know of an easy case where it's definitely false? Well, yes, because it says here that it has to have a number that's less than x. So obviously, if the number we're dividing by, or the numbers we're dividing by, start at or above x, then obviously the correct answer has to be false. So that's an easy case. And we know that these first two lines are correct. Okay, what's another case? Well, I know that if x is in fact divisible by k, well, let's see, if x is actually divisible by k and k is not greater than or equal to x, then the comment here says that if x is divisible by any number greater than or equal to k, well, that must include k, right? Then the answer is true. So if x is divisible by k, then I should return true. So I should return true under and an easy case is where x is divisible by k. Now in Java, you happen to say that by asking, is the remainder when x is divided by k? That's percent. That's the percent operator. If that's 0, then of course it's divisible. So now I know that these first 4 lines are true, even though I don't know the rest are correct, even though I don't know the rest of the procedure. And now we consider the case where k is less than x and x is not divisible by k. When is that going to be divisible by some number greater than or equal to k? Well, it's not divisible by k. We've already determined that. So if it's divisible at all, it has to be divisible by something bigger than k, either k plus 1 or some number after that. So, is there a way of figuring out whether x is divisible by some number greater than or equal to k plus 1? Oh, look, here's a function whose comment says it's true if x is divisible by whatever my argument is. I'll just use that. Hey, wait a minute. You're in the process of defining that function. Never mind. It doesn't matter. I mean, it still looks like, I can just use it's the same principle. I mean, if I could rename this function as is divisible to, and then later on I could go in and implement it by calling is divisible. I mean, who would know? So the fact that, assuming that in fact this comment is correct, this line here will work. And I will get the effect that x is divisible by k if it is divisible if x is divisible by k plus x is divisible by k or larger if x is divisible by k plus 1 or larger. So I have now covered all of the cases, and I know by just reasoning from the comments and from my knowledge of prime numbers and so forth, I know that this function must be correct. It's correct it's correct by construction. There is this little issue of the fact that I have called this function that I was already defining, and maybe that means that my thinking is circular, but we can deal with that some other time, like, for example, Wednesday. So, thank you.